Hey guys, my name is Reno and today I'll be teaching you about points, lines, and planes. Starting off with our point, a point has no dimension and a dot represents a point. So there's our dot and then there's going to be a letter to represent the dot or the point. We're going to need to really remember the definition of a point because we're going to be using this further on in this lesson and lessons to come forward. Alright, now let's look at the definition of a line. So a line has one dimension, unlike the dot which had no dimension, or the point which had no dimension. How we represent a line? A line is represented as a line with two arrows at the end, two arrowheads at the end, and continues on forever in both directions that it's drawn in. So for example, you have a line and if it's drawn horizontally, it goes left to right, vertical, up and down, just like that. And then this is a corollary, this third point right here. This corollary says through any 2 points there is one line. So for example, if there's 2 points A and B, there's one line. 2 points B and C, there's one line. We can use that corollary's information for the fourth point. Use any 2 points on a line to represent it. So for example, if you have 2 points in that line A and B, we can say line AB. This is how we draw a line usually on a piece of paper. So we have our 2 points A and B, and then letter J I'll come back to later. We can represent this as line AB or line BA, and then we can also say line J as a third way of representing the line. Okay, so now looking at the plane definitions, we're gonna say a plane has 2 dimensions unlike the line which had 1 dimension. So a plane is often represented by a floor or a wall and it extends forever. So we often draw this as a parallelogram in geometry, and then this extends in all directions unlike the 2 directions that a line is drawn in. So a corollary that relates to planes is that through any 3 points not on the same line, there is one plane. So for example, if there's 2 points on a line and then 1 point outside the line, there's one plane. Using that corollary's information, we can use those 3 points to name the plane. So here we have our wall type shape, and then we have our line with point A and then point B. Next we have point C, which is outside the line, so we can say plane ABC or plane M. So this letter M is given as another way of representing a plane. If a letter like this is given, then you can say plane M or plane whatever the letter that is given to you. If not, you can use the 3 points that are given to you. Now there's some practice right here. Pause the video, try this out. Before you pause it though, there's 2 words that you might not know: collinear and coplanar. Collinear means they're all on the same line, and coplanar means they're all on the same plane. So now pause the video and try this out. Okay, now that you're back, give 2 other names for line XA. So line XA is right here. 2 other names will be line AX, since we can reverse it because it goes on forever in both directions. Then line M, which is given to us. As I said earlier, only if it's given to us we can say line M. Now for plane O. So for here we can say plane YXZ, as there's 2 points on the line and 1 point not on the line. Next we can say XQZ, 2 points on the line, 1 point not on the line. Okay, so for number 2, name 3 points that are collinear and 4 points that are coplanar. So 3 points that are collinear. We can't use this line because there's only 2 points, but we can use this line since there are 3 points. So the 3 points that are collinear are Y, X, and Q. And then 4 points that are coplanar means 4 points that are in the plane. That would be Y, Z, X, and Q. We can't say A as it's not in the plane. Okay, moving on to the definition of a segment. A line segment is line segment AB or segment AB or segment BA, since we can reverse it as it's. So a line segment is, it's like a line but it has 2 defined endpoints. So for example, right here we have two endpoints. This is a line in the middle, but two endpoints. So this is what we like to call a line segment. Now we can line A and B, and then we would say, for this we would say line segment AB. So these points A and B are known as the endpoints of the segment. So array. So the definition of array. So a definition of array is, here we have a drawing. So array has one defined endpoint and one end that continues on forever. So as I said earlier, for the line and the line segment, we could reverse the letters A and B, but here we can't. Since there's only one end that continues on forever, we can't say array BA, because the endpoint A is there so that the line does not continue forever on the other direction. So we can't say array BA. Okay, so now moving on to our last topic here, which is opposite arrays. Alright, so opposite arrays are pretty simple if you know the definition of array. Okay, so here we have a line here, and then a midpoint C. Here is given if Z is in the middle of line XY, then line ZX and line ZY are opposite. So for example, if C is in the middle of A and B, then CA and CB are opposite rays. We represent a ray with a line with one arrowhead at the right side, representing that it goes to the right. Okay, so this is how we represent the array, and then we say CA and CB. These are opposite rays because they're in opposite directions. CA is going to the left and CB is going to the right. Alright, now there's more practice right here. Pause the video, try this out, come back for the answer. Alright, now that you're back, so here it says give another name for ZN. So this line means line segment ZN. So here it is. Give another name for ZN. We can say NZ. Since it has two defined endpoints, the line does not continue forever or in one direction forever like array, so we can reverse it. So line segment NZ. Now for number 2, name all rays with endpoint X. Which of these rays are opposite rays? So this is our endpoint right here in the middle. And then so for part 1, name all rays with endpoint X. We're going to say ZX, ray NX, ray PX, and ray OX. Now for part 2, which of these rays are opposite rays? It's going to be ray ZX and ray NX. These are opposite because they're in opposite directions. They continue in opposite directions. Ray NX goes this way and ray ZX goes that way. Now ray PX right here and then ray OX are opposite because OX goes this way and PX goes this way. This should be some practice to clear up any doubts about earlier. So this is some good practice. You can search up type of questions on Google and practice this if you're not fully clear on this. Okay, so now this is our last topic, sketching intersections. So this is what we're going to be looking at mainly right now. We're not actually going to be drawing anything, but I will briefly explain it. So when two lines intersect, it's in a point. So for example, point V right here, that's the intersection point of these two lines. Here, these two planes intersect in one line. How are we going to draw this? Drawing is easy. You just draw two lines with two arrowheads each, and then draw a point in the middle. Here, first you're going to need to draw a plane, rectangle, parallelogram, whatever it is, and then draw the other plane going through the middle of it. You're going to want to draw dotted lines for the areas that are going to be behind the first plane. And then draw a line in the middle which says line M as the intersection of both planes. Okay, so now we're looking at a practice word problem. This is the final question. So it asks us name two planes that contain the line M. Pause the video, try this out, look at all the definitions that we've learned so far about the intersections, go review it. I hope you were taking notes, review the questions, and then come back and I'll give you the answer. Alright, now that you're back, let's look at the first step. First, we're going to find line M right here, and then all the points given on line M. So the points that are given to us are line B, line V, and line C. Point C, point V, and point B. Sorry for saying line. Then next, we're going to be thinking about the definition of a plane. So, as we learned, a plane was 2 points on the line and 1 point not on the line. Next, we're going to find 2 points on the line and find 2 other points not on the same line, so we can define 2 planes. So here we're going to take points B and C, or B and V, or V and C, and then we're going to find 1 point not there. So W, for example, K, U, or Z. And then next, we're going to name our planes. So here, an example definition or an example answer could be plane BC, BCW. So this plane right here, there will be a plane right here, or plane BCZ. So you have to make sure that these planes are not on the same direction or the same dimension as this. This plane is going to up here and continues, for example, here. This is horizontal. This plane is horizontal, but this plane is vertical, and it continues up and everywhere around the vertical area. So you need to be careful when you're defining this, because if you say C, B, and U, these are on the same dimension, they're horizontal, so they could be considered as one full plane. So you have to be careful on that. I hope you understood this lesson. I hope it was easy to understand. You can find more practice on many of the websites. Just type up points, the planes, intersections. You can find more practice. I hope you enjoyed the video, and I hope you come next time.